Okay, today we talk about the last section in Chapter 2. We're going to be solving quadratic equations. Okay, so we need to let you know what a quadratic equation is. A quadratic equation is an equation that can be written in the form ax squared plus some bx plus c equals 0. And getting equations equal to 0 is going to be very helpful for us to solve. Okay. Now a, b, and c are real numbers. They could be irrational, but they won't be imaginary. Notice what makes this different is that we have an exponent that we actually write in. This is x squared. Of course, there's an understood x to the first power here. And if we really wanted to, we could write x to the c times x to the 0, because x to the 0 is equal to 1, anything to the 0 power. Okay. So notice all of the exponents are either 0 or positive, and they are whole numbers. Okay, so they are whole numbers. And this will also be known as a polynomial. But it's a specific polynomial because it is a second degree. And second degrees we give the name of quadratic. Okay. So we're going to be studying 4 different methods to solving the quadratic. Okay. You'll be asked to demonstrate that you know how to do all 4 of these methods. Alright, before I explain this one, the first one is dealing with the zero product property. Okay. So let's think about some things that we know. We know this. We know if you take 0 times any number, a, okay, well that just has to be 0. Or if you take a and if you multiply on the right by 0, it's still 0. Doesn't matter. Or if you take 0 and multiply it by 0, you still get 0. Now this is a unique property to 0, to the number 0. That anytime you multiply two things together and get 0, well, it's either that the first thing was equal to 0, or that the second thing was equal to 0, or it could be that both are equal to 0. But the result then is 0. Okay, so that's a unique property. So for example, if I take 8 and I multiply that by x, and that equals 0, well, you could divide through by 8. Okay, so the 8s would cancel and you would get x is equal to. Now 0 divided by anything but 0 is 0. Alternatively, we can think about it in terms of the zero product property. If two things are being multiplied together that are 0, then either the first is equal to 0 or the second equals 0. Now this is clearly a non-true statement. 8 does not equal 0. So the only option we have here is that x is equal to 0, using the zero product property. So that's what this says here for the zero product property. If two things, two unknowns, are multiplied together and they equal 0, then it's either that the first unknown is equal to 0 or that the second unknown is equal to 0. Okay. Or both. That could be true. So for example, that is what we have here. Now notice the important thing here is that this is a multiplication. So here we have two things multiplied together that equals 0. The first is x minus 2. So if x minus 2 times the second thing, which is x plus 5, equals 0, we have two options then. It's either that the first, x minus 2, equals 0, or the second, x plus 5, equals 0. Or they both could be equal to 0. But now these are very simple equations for us to solve. We can add 2 to both sides. So we see that either x is equal to 2, or we can subtract 5 from both sides and see that x is equal to negative 5. Now we might ask ourselves, is this a quadratic equation? Well, let's FOIL this out. If we FOIL it back out, we'll get x squared, and from there we can see this is quadratic. Plus 5x minus 2x minus 10 equals 0. So x squared plus 3x minus 10 equals 0. So this is the quadratic that represents these two factors. But because it was factored, it was very easy for us to split it apart. It was factored in equal to 0. Okay? If it's not equal to 0, this is not true. So let's see if we can apply that to this this next quadratic. 2x squared plus 7x minus 15 equals 0. Okay? It's already equal to 0, so we have no other work to do. Let's see if we can factor this. Okay. Now if I have 2x squared, I only have two choices. Okay? I have to have a 2x and I have to have an x, so when I FOIL these back out, I'd get to 2x squared. Now you can use the AC method or the cross method. I think I'll do trial and error here. I need to get to a positive 7, so I'm thinking that if I work with 3 and 5, this will work. That is, if I took the 5 and that was multiplied by 2, that would be a 10. So let's make that positive. So I have a positive 10 and I'm subtracting then 3. That would get me to positive 7. Now that this is factored, I have two things being multiplied together. The first is 2x minus 3. So it's either that 2x minus 3 equals 0, or that the second, which is x plus 5, equals 0. Now this one's very easy to solve. We'll just subtract 5 from both sides. Here let's add 3. So we have 2x is equal to 3, or, and now divide by 2, or we have the solution that x is equal to 3 halves. And these are two possible solutions. And notice what we had was a second degree equation. Here we also have a second degree equation, and we have two possible answers. And this will be true for all quadratics. They might not be unique, like these are unique, 2 and 5 are different from each other. But we will get two solutions. Okay. Now let's do this next one. Okay. I do have a quadratic. I could set this equal to 0. That means I would have to take 4x squared and subtract 9 from both sides. Now this is still in the form ax squared. Okay? A in this case is 4. We do have a c. C in this case is negative 9. But what about this bx term? Well, there is no x term, so we would take b to be 0. Since 0 times x is just 0. Now let's factor this. This is just the difference of two squares. So we'll need a 2x and a 3. And since it's the difference, we'll make 1 plus and 1 minus. Okay? So we'll get 4x squared minus 6x plus 6x. Well, that goes to 0x. And then minus 9. So it's either that 2x plus 3 equals 0, or 2x minus 3 equals 0. We just solved 2x minus 3 over here. We had to add 3 to both sides and then divide by 2. In this case, we'll subtract 3 from both sides and then divide by 2. So again, second degree equation and two different answers. Now here, we have not a second degree, but we have a third degree. Okay? So let's still try and get this equal to 0. So to do that, I'm going to have to subtract 12x from both sides, get 2x cubed minus 12x is equal to negative 10x squared. Okay. And then we'll add 10x squared to both sides. So we'll have 2 times x cubed. I'm going to write this in descending order. I can do that because addition commutes. Minus 12x equals 0. Alright. So now that I have something equal to 0, I want to look and see what I can do. Well, I can look for a greatest common factor. And I can see in between here, there's a common factor of 2 that I could pull out. And then there's also a common factor of an x. So once I do that, then what I'm left with here is just x squared. If I divide, so I just figured that out by dividing by 2x. That's what I'm pulling out. The 2's will cancel, and x cubed divided by x is just x squared. Okay. Now here, 2 goes into 10 5 times. This will be a plus 5. And x squared divided by x is simply x. And if we divide here by 2x, the x's will cancel, and 2 goes into negative 12, negative 6 times. And that whole thing's still equal to 0. Now, let's see if we can factor this further. Okay, so now the 2x will stay. So to get to x squared, I'll need an x and an x. Plus 6 minus 1. Let's see. Plus 6x minus an x is positive 5x's, and then minus 6. So in this way, I have 3 things being multiplied together that are 0. Okay. But the zero product property still applies here. Okay. It doesn't matter how many in a row as long as they're being multiplied. So it's either that 2x equals 0, or this first x plus 6 equals 0, or this second x minus 1 equals 0. And now these are very simple equations for us to solve, so we know that x is equal to 1. Here, subtracting 6 from both sides, x is equal to negative 6. And here again we can use the logic. If 2 times x equals 0, well, 2 doesn't equal 0, so it must be that x equals 0. So in this way, we got 3 different answers. Okay. And what we had was a third degree equation. And so in this case, the degree, being 3, gave us 3 different solutions. Okay. And the note then says that this method can only be used when you can factor the polynomial, okay? Because again, we need multiplication that is set equal to 0. Okay, so you both need to have factors, and it needs to be equal to 0. It can't be equal to 1 or anything else like that. It needs to be equal to 0. Okay, I hope that makes sense. Okay. Now, there's another method that they call extraction of roots. Okay. This is the one time where it's, well, it's not the one time, but this is a case where we don't necessarily need anything set equal to 0, but we're going to have to remember. Okay. First, let's set this equal to 0 so we can see what we have. We would have x squared minus 9 equals 0. And then if we factor it, this would be x minus 3 times x plus 3 is equal to 0. So then it's either that x minus 3 equals 0 or x plus 3 equals 0. So x is equal to positive 3, or x is equal to negative 3. This is if we would do it by factoring. Okay. Now notice we have a second degree equation, so we have 2 different solutions. Now, we can use this thing called an extraction of roots. Okay. Just write it up here, x squared minus, or is equal to 9. Okay. Now this x squared is isolated. There's no coefficient on it. It's not having anything else multiplied or subtracted or added. Okay. Now I can undo squaring by taking the square root of both sides. Now the square root of x squared is just x, and then we are tempted to say here that the square root of 9 is 3, which is true. But notice we should have two different answers. So when we do it this way, that is, if we take the square root of an unknown, we have to remember to put the plus or minus. So if you factor it, you won't have to remember the plus or minus, although sometimes it might be difficult to factor. Okay. So let's just use that same method here now. Okay. Now if I have x squared is equal to 5, I can take the square root of both sides, and then the square root of x squared is x, which is equal to, and now the square root of 5 is irrational. Okay, it can't be simplified, so we'll just leave it as the square root of 5. But we have to remember to put that plus or minus inside of it, out front of it, sorry. Okay, let's try the next one. Let me rewrite it so we can see it a little bit better. Now what made these nice is that the coefficient on x squared was just 1, so we could take the square root. In this case, we don't have a coefficient of 1, so first let's divide by 2. Then the 2's will cancel, leaving x squared is equal to, 2 goes into 32 16 times. And now we can take the square root to undo this. So we'll have x squared, x, the square root of x squared is just x, is equal to, and now let's not forget, this is an equals to, plus or minus the square root of 16. But we know what the square root of 16 is a perfect square, so our answers are x is equal to plus or minus 4. So if we have the quantity now x minus 1 squared, okay, this is a quantity, there's something inside of here, it's not just x, we can still use the square root to solve this. I could take the square root of both sides. Okay. Now the square root of the squaring will simply leave x minus 1, that quantity. Okay. But that has to be equal to, and don't forget about this, plus or minus, and the square root of 7 doesn't reduce, so we'll just leave it as plus or minus the square root of 7. And now we have this is what x minus 1 is equal to, but we don't want x minus 1, we want just x. So if I add 1 to both sides, we'll get 1, and then followed by the plus or minus root 7. This is two answers. They are irrational. The first one is 1 plus the square root of 7, and the second one is 1 minus root 7. Okay. So let's do the same with this. Let me rewrite it so we can see it a little bit better. Okay, so here, my quantity is being squared, and it's isolated. There's nothing being multiplied outside of here. So we can take the square root of both sides again. Now, the square root and the squaring will undo each other, so we'll just be left with this 2x plus 3 is equal to the square root of 8. But remember, we need that plus or minus there. Now, let's keep solving. We want to get to just x, so we need to subtract 3 from both sides. So we have 2x now is equal to the negative 3 plus or minus the square root of 8. And now we can divide both sides by 2. So the 2's will cancel here. And we'll be left with x is equal to negative 3 plus or minus the square root of 8, all divided by 2. And we have one last thing to do. Okay. We know that the square root of 8 can be simplified, okay, because 8 is 2 times 2 times 2. So in the square root, we're looking for a grouping of 2, and there is one there. So we could pull that out, then puts the square root and anything else that remains, which is just this 2. And we could divide that by 2. Okay. And this is our fully simplified answer. Now in this case, we have a quantity again that's being squared, but it's also being multiplied by negative 2. So let's divide by negative 2. Okay. And the negative 2's will cancel. And on this side we'll have the quantity 3x minus 5. That quantity squared must be equal to, well, the negative and negative become positive, and 2 goes into 18 9 times. Now we'll take the square root. Okay. The square root will undo the squaring, so we'll simply get 3x minus 5. That's what's inside of here. And that has to be equal to, and let's not forget, plus or minus. Now the square root of 9 is 3. Now we can add 5 to both sides. So on this side, we'll simply be left with 3x, and then we have 5 plus or minus 3. Now, up here, when we had this plus or minus situation, we left it because this was an irrational number and this was an integer, so there was no way to combine those. In this case, however, these are both integers and they can be combined. Remember that this is really 5 plus 3 or 5 minus 3. So we have two situations here. It's either that 3x is equal to the first, which is 8, or that 3x is equal to the second, which is 5 minus 3, which is 2. And now we can solve. Let's divide by 3. The 3's will cancel. So we have then that x will be equal to 8/3, or x is equal to 2/3. So we have two answers here, which is fine because we had a quadratic to begin with. So you really need to have some type of either x squared equals a constant or some quantity equal to 8. And this note here says that this is really part of another method. So this is method 2, and it's part of another method called completing the square, which is method 3. Alright, so let me explain to you about completing the square. So the Babylonians had been working on mathematics for a very long time, and they knew how to complete this square a long time ago. So let's say they were faced with this question of x squared plus 6x plus 7 equals 0. They didn't think about it in terms of factoring. They thought about it in terms of geometry. So first that they did is they would add 7 to both sides to get this. So then what they envisioned was, how do I deal with x squared plus 6x in terms of geometry? Well, they thought about it this way. If this square represents x squared, the area of it, then the length of this side must be x, and the length of this side must be x. Okay? So, because the area of a square is length times width, okay? Or side squared, however you want to think about it. Okay? Now, what that means then is that this is also the side of x, and this rectangle also has a side that is the length of x. Now they wanted to think about 6x in terms of area, but there were two places to fill in. So they knew that if they thought about this is 3x and this is 3x, then their sum is 6x. Well, if this area is supposed to be 3 times x, and this side is a length of x, then this side must be the length of 3, so that 3 times x is 3x. And this length also needs to be 3. So now then they thought, well, there must be some area here that would complete and make an entire square. Okay. So what is this area that they would need to add to complete the square so that the square would look like this? So this would be x plus 3 on one side, and this side would be x plus 3. So we're looking for this quantity. So, if this length is 3, that means the length of this unknown side was also 3. And if this length is 3, then the length of this unknown side is also 3. So the area here, 3 times 3 would be 9. How is this helpful? Okay, we have just completed this square, so the area inside of here is x plus 3, that quantity squared, side times side. Okay. Well, what does that have to be equal to? Well, that has to be equal to this, and if we sum up the areas inside of here, okay, so x plus 3 was the quantity squared over here, it has to be equal to x squared plus 3x plus 3x, such as plus 6x, and then plus 9. Okay, so that's what they were thinking of, and now, now that they had completed this square, knowing this, the Babylonians could finish solving. They could finish solving the equation, this equation. Okay. So, notice what we did. X squared plus 6x was equal to 7. So you moved the constant over. Number 7 is the constant because there is no variable attached to it. And then what they realized is if I add 9 to this side, I could rewrite this as this. Okay, so let's do that. So I wanted to add something to both sides, okay? But I can't just add it to one, I have to add it to both, right? And that was 9. Okay, so we added 9. And to maintain the equality, we added it. Okay. Now I'll do this side, it's very easy. 9 and 7 is 16. Okay. But what they noticed then is this x squared plus 6x plus 9. Well, that is the quantity x plus 3 squared. So I could rewrite this. This side is the quantity x plus 3, that quantity squared, being equal to 16. And now we can solve this. If we take the square root of both sides, the squaring and the square root will undo each other, just leaving an x plus 3. And that will be equal to, and don't forget the plus or minus, the square root of 16, which is just 4. And now we can subtract 3 from both sides to get x is equal to negative 3 plus or minus 4. But remember, these can be combined because they're both integers, so it's either that it's negative 3 plus 4 or negative 3 minus 4. So it's either that x is equal to positive 1 for x is equal to negative 7. And that's the method known as completing the square. And so we don't have to write completing the square. If you ever see me abbreviate it, I'll just write CTS. Okay? Since we don't have to write that all the time. So this is the steps that we just did. Now completing this square will only work if the coefficient on x squared is 1, which we had here. Okay? So we didn't have to go through and divide both sides. If the coefficient on x squared is not 1, we're going to have to do some dividing. We'll do an example. Okay. Then we moved the constant to the right side of the equation and all the x terms on the other. We took 6 and divided by 2 to get these 3's. Okay. And that 3 is what that squared to get equal to 9. Okay. From there, then we could write the perfect square and take the square roots and solve. Okay, now we're going to be able to complete the square to solve any quadratic equation. Okay, the first two methods are restricted in which we can do. And this one will work for all. Okay, so let's do some examples, and let me write these on a separate sheet of paper. Okay, so for example, we have 2x squared minus 20x plus 4 equals 0. Okay. Now to complete the square, the first thing we have to have is that the coefficient a, okay, that which is on x squared, must be 1. And it's not 1. So, but we can change that, that's all right. All of these are divisible by 2, so we'll just divide everything by 2. The 2's will cancel here, and we'll be left with x squared. Then 2 goes into 20, negative 10x. And 2 goes into 4 2 times. And anything, 0 divided by anything but 0 is 0. Okay? Alright, so that's step 1. Okay? Now, let's move this constant over so we can just have the x squared terms over here. And I'm also going to prepare to complete the square. That means I know I'm going to add something to this side, so I like to, see, now to move this over I'd have to subtract 2, right, from both sides. Okay. But if I'm going to add something to this side, I have to do it to that side. So I like to put blanks in so I don't forget. Now we need to take the coefficient on, let's see, that was step 2. So this is step 2. Now we need to take, this is step 3. Right? We need to take the coefficient on x, which we need to be careful here, is negative 10. Okay? So negative 10, we need to divide that by 2, which is negative 5. And then we're going to take that result, negative 5, and we're going to square it. Okay. So 25 is what we're going to add to both sides. Okay. So I'm going to add 25 here. And I'm going to add 25 over here. I just like to write it as negative 5 squared. Okay. Negative 5 squared is 25. I'll show you why in just a minute. Now, this is step 4. Okay. Now, this side of the equation, by doing that, is going to collapse into something of the form x some quantity squared. Okay. And the reason why I write it like this is because what's inside of here that is squared, okay, is what we write here. So that minus 5, negative 5 becomes minus 5. Okay, so that's why I like to do that. And then that will equal negative 2 plus 25 is 23. And now we're home free. We just take the square root of both sides. Okay? The squaring and the square root will undo each other, leaving just the x minus 5 is equal to, and don't forget this, plus or minus the square root of 23. 23 is a prime number, so we can't simplify that. And now we just need to solve for x by adding 5 to both sides. So we see that x is equal to this positive 5 plus or minus the square root of 23. So we have two answers. They are irrational. Okay, let's try another one. Now, for example, well, let's look at this for 1 second. Notice what was nice here is that the coefficient on x is even. So when I take it, negative 10, and divide by 2, we come up with a nice answer. Now, in this example, x squared plus 3x minus 6 equals 0. This is not even. That's okay. We can still do this. It's just going to take a little bit of work. So step 1, the coefficient on x squared is 1. Good. Now, step 2, let's prepare to complete the square. So to do that, I leave the x's on one side, and I'm going to add something to that. And I need to move this 6 over by adding 6 to both sides. And remember that we're going to add, whatever I add here, I also have to add here. Okay. Now, we need to take the coefficient on x, which is 3, and we divide that by 2. And that's it. 3 divided by 2 is 3 halves. Right? So we'll leave it like that. Now, 3 halves is what needs to be squared. 3 halves squared means this. And up top we'll get 9 over 4. So the 9 over 4 I write here. And this one I write as 3 halves squared. 3 halves squared is 9 over 4. But why that's going to be helpful is now this side will collapse. And it can be kind of difficult to factor with fractions, but it doesn't matter. Here I have 3 halves, okay? And it is positive, so this will collapse into this. And this will be equal to, now I'm going to have to add 6 to this, so let's get a common denominator here. This is 9/4, so let's get a common denominator of 4. So 24 over 4 plus the 9 over 4. And now let's simplify this. So this is the quantity x plus 3 halves squared, which is equal to 24 and 9. Well, 24 and 10 would be 34, and we'll back it off 1. 33. And now we're almost finished. Let's take the square root of both sides. The square root and the squaring will undo each other, and we'll be left with x plus 3 halves is equal to, now don't forget this, plus or minus the square root of 33 over 4. And now we can subtract 3 halves from both sides. So x will be equal to now a negative 3 halves plus or minus the square root of 33 over 4. But we need to simplify this radical. Remember this, the square root of 33 over 4, we could write that as the square root of 33 over the square root of 4. And why that's nice is then that the square root of 4 is just 2, and up top the square root of 33 doesn't simplify. So this is now negative 3 halves plus or minus the square root of 33 over 2 is what x is equal to. And since these have the same denominator, I could really write it as one great big fraction as negative 3 plus or minus the square root of 33 over 2. So we really have two answers here. Okay, so doing it with fractions is a little bit more difficult, but nothing we can't handle. Okay, so refer back to this anytime you have one that's not, where b is not even. Okay? If b is even, refer to the first example here. Okay? Otherwise, the process is the same. Okay. Now, let's do this in general because I've said that we can do this for any quadratic equation. And I also said at the beginning that any quadratic equation could be written in the form ax squared plus bx plus c equals 0. Okay. Now let's complete the square. Right? To complete the square, we have to make sure that the coefficient on x squared is 1. In this case, it's not. It's some unknown a. So let's divide everything by a. Now the a's will cancel here. So we're left with x squared plus, now let me do this over here, bx over a. We could write this as b times a over x over 1. 1 times a is a, and b times x is bx. Which means that we could write bx over a as just b over a times x, because x divided by 1 is just x. So what that means then is that the coefficient is on x is b over a. And our constant term is just c over a. And 0 divided by anything but 0 is 0. And a cannot equal 0, because if a was equal to 0, then the x squared term would go away, and we'd have just bx plus c. So it's possible for us to divide by 0. If we had just bx plus c, that would be linear, not quadratic. Okay, now let's prepare to complete the square. I need to move this over. So x squared plus b over ax. Going to add something to this side. And how do I move this over? Well, since I'm adding c over a, I'm going to have to subtract c over a from both sides. And then I'm going to add in that blank, because I have to remember to do it from both sides. Okay. Now, that's step. Well, which step is that? Step 2? Okay. Now, in step 3, we have to look at the coefficient on x, which is b over a. Now, b over a needs to be divided by 2. Well, what are we going to do with that? Well, remember we could write 2 as 2 over 1. Okay. And when you're dividing fractions, you have to invert and multiply. So dividing b over a by 2 is the same thing as multiplying b over a by a half. Which means I could write this as b over 2a. Okay, so that's dividing this in 2. And now what we have to do is we have to take that b over a and square it. Okay, so that's b over 2a. And b over 2a. Okay. So once I square this, this becomes b squared over 2 times 2 is 4, and a times a is a squared. Okay. So taking the coefficient, dividing by 2 gives us this result, and then we have to square that. Okay. is what we write up here, which is b squared divided by 4a squared. That's what I'm going to add. And remember, I'll write this form over here. Now that I've added this result, this side will collapse because it's a perfect square. It's going to collapse into x some quantity squared. And what's nice about writing it this way is that I can take this inside of here, this b over 2a, and it is positive. And so that is how this will factor. Okay? I don't try and factor this in my head. I just know that this is how it's going to factor. Okay? And this will be equal to, now these are just fractions. Okay? I want to combine them. If you're going to add fractions, you need a common denominator. So our least common denominator is going to be 4a squared. So this side already has 4a squared, so I don't have to touch it. But I need to multiply this by 4 and a, and therefore this one by 4 and a. So that means our least common denominator here, I could write it as one big fraction, 4a squared. This becomes negative 4 times a and c. Remember that this multiplication will compute. So commute. So negative c times 4 times a is the same thing as negative 4 times a times c. And then we just leave the plus b squared from here. Okay. So now x plus b over 2a squared. Before I take the square root, I'd like to just change this so the negative isn't out in front. We can commute these. So this becomes b squared minus 4ac all over 4a squared. Alright, and now we're home free. Okay. Now that this is quantity, it is squared, I can just take the square root of both sides. Okay. Then the squaring and the square root will undo each other, and I'll just be left with what's inside of here, which is x plus b over 2a, and that must be equal to plus or minus, don't forget your plus or minus, just the square root of this side. 4a squared. Okay. Now, let's split this radical up because 4a squared is a perfect square. So in the next step, we have x plus b over 2a, just copying the left-hand side, must be equal to plus or minus. Now, the square root of the numerator, which is b squared minus 4ac, divided by the square root of the denominator, which is 4a squared. Okay, so we'll simplify that. X plus b over 2a is equal to plus or minus. Now there's nothing we can simplify with b squared minus 4ac. However, the square root of 4a squared, well, that's the square root of 4 times the square root of a squared. The square root of 4 is 2. The square root of a squared is just a. And so this is equal to 2a. And that's going to be really helpful because the next thing I want to do is solve for x. So let's subtract off this b over 2a from both sides. Now this will go to 0. B over 2a minus b over 2a is 0, leaving just x. And then we'll put this negative b over 2a out in front and leave our plus or minus the square root of b squared minus 4ac all over 2a. And I hope people can see what has happened here. Okay. Now let's get a common denominator. We already have it, 2a and 2a. So as we write it as one big fraction, we take the first, negative b, and then plus or minus the second, the square root of b squared minus 4ac, that entire quantity over 2a. And that is what the result of the solution to any quadratic must have the form of. And because this is very explicit, that is, we can solve any quadratic in terms of its coefficients a, b, and c. This is also known as the quadratic formula. And this is what another method, our fourth method, that you will be asked to demonstrate. Okay. So this result is what you need to write up here, if ax squared equals that. Okay. You will need to know this. Put it on your flashcards. Now let's do an example on page 79 of solving this. Okay, let's see if I can do it in here. Okay, so let's say this is our formula, or not our formula, our quadratic that we have to solve. Now, let's identify what a is. A in this case is 2. B in this case, now there is no coefficient on x, so remember, anytime we don't see it, it's an understood 1. And we also have to be careful here that c then is subtracting 3, so we'll take that to be a negative 3. Because we're adding c up here, so we need to, if we're subtracting, it needs to be a negative. Okay, so here we go. X is equal to, and anytime you do this, write down the equation. It'll help you memorize it. Negative b plus or minus the square root of b squared minus 4ac, all of that over 2a. Now let's start substituting in. We have negative from the formula, and what is b? Well, b is 1. Plus or minus the square root of b squared, which is 1, minus 4 times a, which is 2, times c, which is negative 3, and then all of that goes over 2 times a, which is 2. So this is step 1, properly substituting this in. Okay. And make sure this division bar comes all the way out here. Don't just let it hang there. Okay. Everything has to be divided. Okay, now let's start simplifying. Okay. Negative times positive 1 is negative 1. And then we'll take plus or minus, and the square root will stay. 1 squared is 1. Okay. Now in here we have a little bit of work to do. I always work with the signs first. So here I have a negative times a positive, so that'll be negative, times another negative will be positive. Okay. Now I can deal with the numbers. 3 times 2 is 6, and 6 times 4 is 24. And then we divide that by 2 times 2 is 4. Which is equal to, now simplifying up top, negative 1 plus or minus, now the square root, and this becomes 25 over 4. Now we can simplify the square root of 25. We know that's just 5. So this is equal to negative 1 plus or minus the square root of 25, which is 5, over 4. And now these are integers, so we really have two different expressions. It's either that negative 1 plus 5 over 4 is our answer, or negative 1 minus 5 over 4 is our answer. And this will simplify. Negative 1 plus 5 is 4 over 4. And here, negative 1 minus 6 is negative 7 over 4. And 4 over 4 will reduce to 1, so it's either that x equals 1 or x equals negative 7 fourths. Okay. These are our two solutions. Okay, so it takes a little bit of work to simplify that. And so that's what these next three examples are, is to help us do some simplification without going through the whole process of the quadratic formula. So let's look at those. Okay. So for example, if we have negative 4 plus or minus the square root of 12 over 2, let's say we had solved and we have this is what x is equal to. Now, we have to simplify this, okay? Always simplify your radicals if possible, so let's start there. Okay. Let's see what we can do with the square root of 12. Okay. Well, remember how to simplify radicals. We need to take the prime factorization. So 2 goes into 12 6 times. 2 goes into 6 3 times. So what that means then is that I could write this as negative 4 plus or minus, and all this over 2. Okay. There's a group of 2's here, so I can pull that grouping out as 2, and then what's left behind, which is this 3, goes back underneath the radical. Okay. So the square root of 12 is 2 roots of 3. Okay. Now there's more simplification we can do. Let's split this up. This is negative 4 over 2 plus or minus, and then 2 over this term. Okay. The first term divided by the denominator and the second term divided by the denominator. And why that's helpful then, as you can see here, these 2's will cancel. And 2 will also go into here. 2 goes into negative 4 negative 2 times. So we really could write this as negative 2 plus or minus the square root of 3. Okay, let's try another one. Example, 3 plus or minus the square root of 18, all of that divided by 3. Okay. Let's simplify the square root of 18. Okay. So 18, finding the prime factorization, 2 goes into 18 9 times, 3 goes into 9 3 times. So this is equal to 3 plus or minus all over 3. Okay. Now the square root of 18, there's a group of 3's, so I can pull that out. And then underneath this radical, I just have to put what is left, and what's left there is 2. Okay, so square root of 18 is 3 times the square root of 2. Now let's do the same thing we did up here and rewrite this. So this is written as one great big fraction. We could take the first term over the denominator, plus or minus the second term, which is 3 square roots of 2 over 3. And then we can do the simplifying. This will cancel, and this will cancel. So in this part, we're left with 1 plus or minus the square root of 2. So, for example, if we have negative 5 plus or minus the square root of 50 over 10. Okay. The process is still the same. We need to simplify what's under the radical. So let's look at the square root of 50. Okay. So taking the prime factorization of 50, 5 goes into 50 10 times, and 5 goes into 10 2 times. So what that means is we could write negative 5 plus or minus. We can write the square root of 50. Here's a group of 5s, so I can pull that out. And then underneath the radical, we have to put what's left, which is just this 2. And then we divide it still by 10. Now, okay, so there we've simplified the radical. Now let's split it up. So it's either that it's written as one great big fraction. We could split it up as negative 5 over 10 plus or minus 5 root 2 over 10. And now we can simplify. 5 goes into itself 1 time and into 10 2 times. And the same here. Notice when I'm simplifying, I do not touch what's underneath these radicals. Okay. So this is equal to negative 1/2 plus or minus 1 times root 2 is just root 2 over 2, which we could rewrite as one great big fraction again. So negative 1 plus or minus root 2 over 2. So it's not that we're always going to be able to get rid of those fractions, but we may be able to simplify them. Okay, let's go to page 80 and do some more examples of the quadratic equation. Now, b squared minus 4ac, that's what we found underneath this radical here. Okay, this is called the discriminant. Okay. And if this ever goes negative, this discriminant, if it goes negative, then we're not going to have a real solution. Okay, so like say if b squared minus 4ac equals negative 2, we're taking the square root of a negative number, and the square root of a negative number is imaginary. So that's what this is saying. So let's work through these solutions, these quadratic equations, and see if we can't determine what's happening here. Okay, so probably should just do that on the sheet. All right, so for example, x squared plus 2x minus 6 equals 0. Great, this thing is equal to 0, and that's an important thing. Okay. So once we have that, we can determine that a is equal to, what will a be equal to? Remember, if we don't see a coefficient, we can always put 1 there. So a is equal to 1. B will be equal to 2, positive 2. And C, we're going to have to remember we're subtracting 6. So C is equal to a negative 6. Alright, now let's write down our quadratic formula. X is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay. Write this down with every homework problem that you do so you can get it memorized. Okay. Now, this is equal to, let's start substituting in. We have a negative from the formula, and b is 2. Then, plus or minus the square root of b squared, and b is 2, minus 4 times a times c. So a is 1, and c is negative 6. Let's make sure this goes all the way over it. And then we divide that entire thing by 2 times a, which is 1. Okay, so that's the proper substitution. Now let's start simplifying. Well, from here, a negative times positive 2 is negative 2. Then plus or minus the square root. 2 squared is 4. Now, I'll deal with the signs first. Here we have a negative and a positive. That's negative. And a negative times a negative becomes positive. Now, now I can deal with the numbers. 4 times 1 is 4, times 6 is 24. And then we divide that by 2 times 1 is simply 2. Okay, so that's equal to negative 2 plus or minus the square root of 4 and 24 is 28. And that gets divided by 2. Now we have to simplify the radical. So let's take the prime factorization of 28. 2 goes into 28. Well, 2 goes into 1 one time. 2 goes into 8 4 times. Okay. Then 2 goes into 14 7 times. So this is equal to negative 2 plus or minus. We're going to divide it all by 2. Well, the square root of 28, there's a group of 2's, so I can pull that out. And then we'll take the square root, and we have to put what's left over, in this case 7, back underneath. Okay, now we can split this up. So this is negative 2 over 2, plus or minus 2 roots of 7 over 2. Okay, just putting it back into 2 fractions. Here, the 2's will cancel, and 2 goes into negative 2, negative 1 times, so our answer is negative 1 plus or minus root 7. So we have 2 solutions, and they are irrational. It's the negative 1 plus root 7, and the negative 1 minus root 7. Okay? These are irrational numbers. Okay, let's try another one. 3x squared minus x plus 2 equals 0. So this is really not one that I would want to complete the square on at all. The coefficient on x squared is 3, so I'd have to divide everything by 3. That would give me negative 1/3 here, and while it could be done, it's going to be messy. So this is definitely one that I prefer to use the quadratic equation on. So first, let's identify. A is equal to 3. Now B in this case, remember there's an understood 1 here, and it's negative because we're subtracting. And then C is equal to 2. Okay, so now let's write down our quadratic formula. X must be equal to negative b plus or minus the square root of b squared minus 4 times a times c, that entire thing divided by 2 times a. Alright, let's begin substituting. Negative b is negative 1. Then plus or minus the square root. We're going to take b and square it. Remember, b is negative 1. Then minus 4 times a and times c. A is 3 and c is 2. And then we divide that whole thing by 2 times a, which is 3. Go ahead and start simplifying that. So here the negative and negative 1 will become positive 1. And then plus or minus the square root. Now be careful here. Negative 1 times negative 1 is also positive 1. Now with the signs, we have a positive and a positive, which is positive, times a negative, which is a negative. Then I can deal with the numbers. 4 times 3 is 12, times 2 is 24. And we will divide that by 2 times 3, which is 6, which is 1 plus or minus. We'll divide this by 6. And here's what happens under the radical then. 1 minus 24 is negative 23. Okay. Now notice, underneath the radical this became negative. That is, the discriminant, b squared minus 4ac, was negative. So when we have this, we still have two different answers, but this forces it to become imaginary. That's an imaginary number, and we get complex solutions. So for right now, this is sufficient to leave your answer as, and just to know that this is going to become imaginary, which will also lead us to complex solutions. Okay? Imaginary numbers with the real numbers are complex. Okay, let's do the last one. So for example, we have 3x squared is equal to 6x minus 1. Now, from here, we might be tempted to say a is 3, b is 6, and c is negative 1. But we need it in the form ax squared plus bx plus c equals 0. It needs to be equal to 0 first, before we determine what a, b, and c are. Alright. Well, we can do that. That's no problem. Let's subtract 6x from both sides. So this is 3x squared minus 6x. And while I'm at this, can I just add 1 to both sides as well? So we don't have to do it in 2 steps. And now this equals 0. Now that we have it in this form, now we can determine that a is equal to 3, b is equal to, remember, since we're subtracting 6x, it's going to be negative 6. And now c is equal to positive 1. Okay, so let's begin solving. X is equal to negative b plus or minus square root of b squared minus 4 times a times c, that entire thing divided by 2a. Now let's begin substituting. Okay, so we have a negative b, so we substitute in 6, and plus or minus the square root. Now b has to get squared, but b is negative 6, minus 4 times a. What is a? A is 3, times c, which is 1. And all of that will be divided by 2 times a, which is 3. Okay, so now from here, a minus 6 is a positive 6, plus or minus the square root. Negative 6 squared is positive 36. Then with the signs, minus and a positive is negative, times another positive is negative. So we're subtracting. 4 times 3 is 12 times 1. It's 12, so that's what this becomes, minus 12. And then we divide that by 2 times 3, which is 6. Which is equal to 6 plus or minus all over 6 And underneath this radical, 36 minus 12 is 24. We're almost done. We just need to simplify this radical. So 24, finding the prime factorization, 2 goes into 24 12 times, and 2 goes into 12 6 times, and 2 goes into 6 3 times. Okay. So what that means is we can have 6 plus or minus. Now, the square root of 24, there's one group of 2's. Okay, so that's 2. That can come out. Now everything else that doesn't have a pair has to go back under, and we will multiply it. So this 2 times this 3 has to go back underneath over 6. And just to be very clear about what that is, that's 6 plus or minus 2 roots of 6 over 6. Alright, now let's split it up. Okay, so this is 6 over 6 plus or minus 2 roots of 6 over 6. Now here, well, 6 over 6, well, that's just 1. Okay. And here, I can only cancel with what's outside. I can't cancel underneath the radical. So 2 goes into itself once and into 6 3 times. So what this becomes is 1 plus or minus 1 times root 6 is just root 6 over 3. Okay, I hope this makes sense. There's a lot in this homework. Okay, so that's the discriminant. Okay. So in the first bit, you're asked to solve this by factoring. Okay. Remember, show all of your work. Okay. This extraction of roots, this is where you can just take the square root, and don't forget to put your plus or minus signs in. Now here, you need to solve these twice, so leave yourself plenty of room. Okay, so you should have 26a, completing the square, and 26b, the quadratic formula. Okay, and you'll do that for each of these. Then this is kind of like a potluck. These are various types of quadratics, and you get to choose the method. Okay, make sure you simplify your answers. Okay, the same with up here with your quadratic formula or any of them. Make sure that your radicals are reduced. Okay, so this is going to take some time. Okay, so there's 42, but you have to do these two twice. So in the end, there's 52 problems here, and here are the answers. For 26 through here, you should get the same answer whether you complete the square or the quadratic formula. Okay. So this is going to take some time, so make sure you get started on it right away. Email me if you have any questions.